Dear grade 6 students, let's have a look into these topics that I've mentioned. Once you understand the concept of solving questions related to these topics, you will find it easier to do your problem solving for your semester 1 final exam. Let's see how to do decimal addition. So if you have two numbers like 23.46 plus 0.5, what do? Always make sure that the decimals come one below the other. So 23.56, and you make sure that your decimals come one below the other. So the final answer will be 23.96. This is when you add two decimals. Suppose the question is to add 5 plus 0.36. So what do you do here? Suppose you have 5, it's similar to 5.0, right? So you write it like this, plus 0.36. So what did I tell you? The decimal should come one below the other, 0.36. And now you write, from this place, 6 and then 3 and finally the 5. So this is how you do decimal addition. In order to do decimal multiplication, what do? If the question is 23.46 into 0.5 multiplied by 0.5, you multiply the numbers normally. So that means 2346 multiplied by 5. You do a normal multiplication. So 11730 is the final answer. Now here, see how many numbers are there after the decimal. I have one number here, okay, and here I have two numbers after the decimal. So altogether 3 numbers after the decimal. So in your final answer also, you should have 3 numbers after your decimal. Let's look into this question, 5 and 0.36. Suppose I multiply 5 with 0.36. So multiply 36 with 5. I told you, normal multiplication without the decimals you do first. 6 5s are 30, 0, 3 balance, 5 3s are 15 plus 3, 180. How many numbers are after the decimal in this question? Here I don't have any decimal. Here I have 2 numbers after the decimal, right? So in my answer also I should have 2 numbers after the decimal. Okay, in the final answer, I'll make sure that I put the decimal so that I'll have 2 numbers after this. This is how you do a decimal multiplication. Now let's see how to do a fraction multiplication. In order to do 2 by 3 into 5 by 6, first you have to do the cutting method, wherein you make sure, is there any relation between the numerator and the denominator? All these numbers on the top are called as the numerators, and the numbers below are known as the denominators. So never look for a relation between the numerators. Always check any relation between 2 and 3. No, I haven't seen them in any multiplication table. Any relation between 2 and 6? Yes. In the multiplication table of 2, I have seen 2 and 6. I'll do 2 into 1 gives me 2. 2 into 3 gives me 6. So what am I doing here? Once I see a relation, I'm dividing with that particular number. Okay, so here I divided with 2, here I divided with 2. And I got 1 and 3. Now, any relation between 5 and 3? No relation. So that's the final answer. I multiply 1 and 5. It gives me 5 over 3 into 3 gives me 9. That's the final answer. Again, let's do another question. 16 by 5 times 25 by 8. Any relation between 16 and 5? No. 16 and 8? Yes, I've seen it in 8's multiplication table. So 8 into 1 gives me 8. 8 into 2 gives me 16. 5 into 1 gives me 5. 5 into 5 gives me 25. Now, okay, I have 1 in the denominator. 1 into 1 is 1. 2 into 5 in the numerator gives me 10. So 10 divided by 1 is the same as 10. The final answer is 10 here. This is how you do a fraction multiplication. Okay. Now in fraction multiplication, you will also have to know how to convert a mixed number to a fraction. Now, what do you mean by mixed number? Let's see what is a mixed number, or let the topics be here. Okay. Now what is a mixed number? If I have 3 and 5 by 7, this is a mixed number. I need to multiply this with 4 by 3. Now what do? Convert the mixed number to a fraction. How do you convert a mixed number to a fraction? You multiply these two numbers and add it with 5. So what do? You multiply the numbers and you add it with 5 and you write the same denominator. So 7 3s are 21 plus 5. 22, 23, 24, 25, 26 over 7. Okay. 26 over 7 into 4 by 3. Now any relation between 26 and these numbers? No. Any relation between 4 and these numbers? No. So what do? You simply, if there is no cutting possible, multiply the numbers. 6 4s are 24. So 104 divided by 21 is the final answer here. Clear? I'll show you how to do one more mixed fraction conversion. 5 and 3 by 4. What do we do here? 5 4s are 20 plus 3. Okay, this is what I did. 5 4s are 20 plus 3 divided by 4. That is the way to convert it. So that gives me 23 over 4. Now that's how you convert a number. And then if the question is 5 and 3 by 4 times 1 by 2, what do? 23 by 4 times 1 by 2. No relation between 23 and 4 or 23 and 2. So I'll simply do 23 times 1 is 23 and 4 times 2 is 8. That's the final answer. Now let us find out how to find the least common multiple of 3 and 9. What do? You write the common multiple. So what are the multiples of 3? 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. And what are the multiples of 9? 9 1s are 9, 9 2s are 18. See, which is the common multiple here? Least common multiple is 9 over here. Correct? If I have 3 and 7, what is the common multiple? Let me write the multiples of 3 first. Okay? So the multiples of 3 are 3 1s are 3, 6, 9, 3 4s are 12, 3 5s are 15, 3 6 are 18. Let me try for 7 also. Multiples of 7 are 7 1s are 7, 2s are 14, 21, 7 4s are 28. Now here, I didn't see any common multiple till now. So let me continue. 3 6 are 18, 3 7s are 21. See, now I have a common multiple. So now this is known as the least common multiple. Okay, LCM means least or lowest common multiple. You know, in the multiplication table, which is the lowest number which is common. That is known as the LCM. Clear? Suppose I ask you to find out the LCM of 3, 9 and 15. So then what do? You have to write down the multiplication table of 15 also now. 15 1s are 15, 15 2s are 30, 15 3s are 45. You write like this and then see which number is common when you write the multiples of 3, 9 and 15. You will see that 9 into 5 will give you 45, and then in 3's table also you will see 45. But see, here the problem is that the students won't know that in the multiplication of table of 3, 45 comes, right? So now I'll show you one more method. In case it's okay for you, you can follow this, okay? So 3, 9 and 15, I want to find the LCM. You write it like this. Instead of writing 3 divided by 3, the way that we normally do. You know, no, 3 1s are 3 and you write a balance. Similarly, I know that 3, 9 and 15, it is there in the table of 3. 3 1s are 3, 3 into 3 is 9, 3 into 5 is 15. Okay. Now see, 1, 3 and 5 is not in any other multiplication table. To find the LCM, what do? You multiply all these numbers. That is 3 into 3 into 5. You will see that it gives you the answer 45. Okay, that's another way to find the LCM instead of doing all this. So suppose I see 3 and 9. What do I do to find the LCM of 3 and 9? So I'll write 3 and 9. I know they are in the multiplication table of 3. 3 1s are 3, 3 3s are 9. Done. Now I don't have anything more to do here. I'll circle the numbers. So the LCM is 3 into 3, which gives you 9. Okay, so this is another way to find out the least common multiple. Now let's try. So we did LCM. Okay, now let's see how to find the prime factors of a number. So this is known as prime factorization. How do you find out the prime factors? So if I want to find out the prime factor of 36, what will give me 36? I know that 2 times 18 will give me 36. Okay? Or maybe some of the students know that 9 into 4 will give them 36. So let them write it like this. Now 9 again as a tree you draw. 3 into 3 will give you 9. and 2 into 2 will give you 4. Now nothing more, right? Now what is the prime factor? 36 is equal to, you write it as a product of all these numbers. 3 into 3 into 2 into 2. Maybe you can write it in the order, okay? First comes the 2 and then comes the 3. See, 2 2s are 4, 4 3s are 12, 12 3s are 36. Okay, so this is how you do the prime factors. Now 36, I'll write another way is this. I multiply 9 into 4 will give me 36, 2 into 18 will give me 36. Now 18 again I'll break it into 2 9s are 18. 9 again I'll keep it as 3 3s are 9, right? Now 2, I don't have anything more. 2 is already a prime factor. So these are the prime factors. Let me multiply all of this. See, I get the same answer. 2 2s are 2 into 2 into 3 into 3. Correct? If I take another number 50. Okay, so this is another question. What will give me 50? You know 5 into 10 will give you 50. I know 2 into 5 will give you 10. Done. Correct? Why? Because 5 is already a prime factor. What do you mean by prime number? Or what is prime factor or prime number mean? Any number like 2, 5, 7, these numbers just have 2 and 1 as their factor. 5 and 1 as their factor. 7 and 1 as their factor. 6 is not a prime number. Why? Because 2 into 3 will give me 6. 6 into 1 will give me 6. There are different numbers like 2, 3, 6 which are all the factors of 6. So this is not a prime number. Any numbers which have only 1 and the number itself as a factor is known as a prime number. Okay. So here what is the answer for 50? It is 2 into 5 into 5. I'll write it as a product of all of these numbers. Okay. So this is known as prime factorization. And now let's also look into, see this one. What is it? Fraction division, which is actually easy. See, I told you here how to do fraction multiplication, right? I'll write it here itself. So 2 by 3 times 5 by 6. If the question was 2 by 3 divided by 5 by 6, it's very easy. You keep the first number as such, put a multiplication symbol, write down the reciprocal. That means you invert these two numbers. 5 by 6, you write it as 6 by 5. Now the answer is 12 divided by 15. Clear? Or what did I tell you to do? I asked you to do the cutting method, right? 2 doesn't have a relation with 3 or 5. Relation means I'm talking about, have you seen them in any multiplication table? I haven't seen 2 and 3, 2 and 5 coming in any multiplication table. But 3 and 6 I have in the table of 3. So let me divide with 3. 3 1s are 3, 3 2s are 6. So now the final answer is, what is the final answer? 2 into 2 is 4 and 1 into 5 is 5. 12 by 15, you got it with, because when you didn't do the cutting method, you got it as 12 by 15. 12 and 15, I have a relation. I have seen it in the table of 3. So 12 divided by 3 is 4, 15 divided by 3 is 5. See, I'll get the same answer. Understood? Without the cutting method, this is the way I go. With the cutting method, I'll go directly to the final answer. Without the cutting method, I'll come here. 2 into 6 give me 12, 3 into 5 give me 15, and then I'll have to make it smaller to get the final answer, which is 4 by 5. These are known as equivalent fractions. Okay, these are all equal. They are all the same thing. You call it as equivalent fractions. Now let's see how to divide the whole numbers. For example, if you have a question like 800 divided by 5, how do you divide the whole numbers? I saw that some students still have a problem here. You take the first number. 5 ones are 5. You get 3 remainder. You're subtracting. Then you bring down the 0. 5 into 6 gives you 30. Remainder 0. Now you bring back your 0 here. 5 into 0 gives me 0. Okay, so the final answer will be 160. Another example, 753 divided by 3. I'll take the first number. 3 2s are 6. 1 remainder. I'll bring down the 5. 3 into 5 gives me 15. Remainder 0. Now bring down the 3. 3 into 1 gives me 3. Remainder 0. Now this is known as the quotient. Okay, the answer that you get is known as the quotient. And this is known as the remainder. Whatever remains is the remainder. Clear? So this is how, these are all known as whole numbers. You're dividing two numbers, and this is the way to divide two numbers. Have a look into these questions too. Now you should know that when you have a number line, the middle number, this is 0. All the numbers to the right are positive, like +1, +2, +3. All the numbers to the left are -1, -2, and so on. Clear? What is the opposite of +2? It is -2. The opposite of 3 will be -3. You should know what are the opposite of any number. And opposite of -2, what am I saying? Opposite, okay? What is the opposite of -2? It is +2. Now if I ask you, where is 1.5? Where will be 1.5? It is between 1 and 2, correct? It's between 1 and 2. And 0.5 means it's like 50, right? 50. So if it will be in the middle, it's half. If there are 100 places here, the 1.5 means it's in the middle. Suppose you have to locate 1/3. Where does 1/3 lie? On the number line between 0 and 1. See, if you want to locate, if it is a number above 1, then you will have it like 1 and 1/3. Understood? If it is after 2, you will get it as 2 and 1/3. Now my question is just to locate 1/3. So what do? Between 0 and 1, you will put 3 divisions because your denominator is 3. You divide it into 3 parts. Okay? And then 1 out of 3 means here. This will be your 1/3. Okay, so imagine you have a small cake with you. 1 out of 3 means you're cutting your cake into 3 equal portions. So maybe this is one portion, and this is the second portion, and this is the third portion. 1/3 means 1 out of the 3 portions. So similarly here, out of your one small piece of cake that you have, or a chocolate that you have, 1/3 means this portion, okay? So here will be your 1/3. Suppose I am asking you to locate where is 1 divided by 8. What do you mean? Between your 0 and 1, you'll put 1, 2, 3, 4, 5. How many are there? 1, 2, 3, 4, 5. Oh, I'll have more. 6, 7, 8. Okay, let 1 be here, okay? So between my 0 and 1, I have 1, 2, 3, 4, 5, 6, 7, 8. So this is a chocolate. I cut it into 8. Now 1 out of 8 means this one. Okay, I'll just have 1 chocolate out of my 8 chocolates. If they ask you to find out where is 5/8, so 1, 2, 3, 4, 5. This will be my 5th chocolate. 5 out of 8 will be here. The same way, if I want to mark -5/8, I'll go to the opposite side. I'll cut it into 8 times, and then the 5th portion to the left will be my -5/8. Clear? If I want to mark 7 and 1/6, so what does it mean? From 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like this I have a number line. Since I have 7 chocolates that I ate, see, so it's going to be after 7 and before 8. So between 7 and 8, I'll make 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. I have 6 portions, and this here will be my 7 and 1/6. Okay, after 7, I take 1 portion out of the 6 portions I have. Clear? So this is how you locate a fraction on the number line. Now what about locating a decimal on the number line? The same number, if it's a fraction, you locate like this. Suppose 1/6, you can also, I want to locate 7 1/6. Okay, I can even write 1/6 like this. 1 divided by 6 means, see, I cannot, 6 doesn't go in. 1 chocolate, you can't divide it with 6 people, no? So you put a point and then you put a 0 here. 6 ones are 6, you get 4 remainder. Then again, you can put a 0. 6 6 are 36. I'll get a 4 remainder, and so on. So now it is like 0.16. So that means before your 7.1, right? It's going to be 7 and then 0.16. Clear? So it is so it's between 7 and after 7.1, it's going to be somewhere here, because it says no 7.1 and then comes your 6 also. So before, next number will be 7.20, right? 7.1 and then comes your 7.2. So 7.16 is somewhere going to be between 7.1 and 7.2. So like this you can convert a fraction into a decimal also. So this you might have a small difficulty finding out what is 3 divided by 4 and so on. 3 divided by 4 you can't divide. You imagine in real life you can't give 3 chocolates to 4 people. So you put a point, you put 0 here. 4 sevens are 28, you get 2 remainder. Now what do? I told you you have the freedom to put zeros. You put 1 0, 4 into 5 gives you 20. Okay, so 0.75, each person will get 3/4 of a chocolate. You can't give him full chocolate. If you have 3 chocolates to be divided with 4 people, you can give him 0.75. Okay, that is 75% of 1 chocolate you can give him. Let me try another one. 4 divided by 7. Okay, I can't give 4 chocolates to 7 people. I put a point, I put a 0. Now 7 into 5 gives me 35. I'll get 5 remainder. Now you're free to put zeros. I'll put one more 0. 7 into 7 gives me 49. I'll get 1 remainder. Now again I can put a 0. 7 into 1 gives me 7. I'll get a 3 remainder. Now I needn't continue like this. You can stop it here. So you know now 4 by 7 is equal to 0.571. Okay? That's how you convert a fraction into a decimal. So we did dividing whole numbers too. Decimal. Okay, so I think I'll stop here. Maybe you can figure out how to do the remaining. It's already all what do I say? Now it's almost a 20-minute video, right? So I'll stop it here. Now try to figure out decimal division and ordering the fractions. Let me just do fast an ordering of fraction also. If I have 4 by 3, 2 by 7 and 3 by 9. If I have to order these fractions, first you have to make the decimals the same, the denominators the same. So find the LCM. I taught you earlier how to find the LCM. Which number goes here? Maybe the 7 remains as such, right? So let me write 3 1s are 3, 7 keep it as such, 3 3s are 9. Done. Okay, so now 3 into 3 into 7 will be the LCM. 3 3s are 9, 9 7s are 56 is my LCM. So keep all the denominators as 56 so as to compare or order the numbers. So what do? 3 into how much gives me 56? So here 56. So to get 56 I have to do, no, it's wrong, right? Wait. Yeah, 9 into 7 is 63, that's right. 3 3s are 9, 7 9s are 63. Okay, so my denominator will be 63 everywhere. Now 3 into 2, 3 into 1. So I'll multiply my 4 also with 21. Now 7 into 9 gives me 63. Here also multiply with 9. 9 7s are 63. Multiply here also. So now 21 into 4 will be 84 by 63. 18 by 63. 21 by 63. Now tell me which number is small. 18 out of 63 is small. Then comes 21 out of 63 and then it will be 84 out of 63. So out of these 3 numbers, so that means 18 by 63 is 2 by 7. See this one.